Hello students, last time we have dealt with the numerical part of this radioactivity and now we will be dealing with a new aspect of this radioactivity and that comes under the heading group displacement law. This group displacement law was proposed by three scientists named Russell, Soddy and the last one was Fazans. Basically, this group displacement law deals with the position of elements in periodic table after the radioactive disintegration. As we know that all the elements are arranged in the modern format of periodic table according to their atomic number, and due to the alpha and beta decay, atomic number of elements atomic number of elements get affected. As we know that whenever the emission of alpha particle occurs, this atomic number it decreases by the value 2. And same for this, whenever the emission of beta negative particle occurs, atomic number increases by the value 1. So since the atomic number gets affected due to the alpha and beta decay, due to the affection on atomic number, now the daughter nuclei will be having different position in the periodic table in regard to the position of parent nuclei. For example, if I talk about the element polonium, so it has the atomic for example, if I talk about the element polonium, so it has the atomic number 84 and the mass number it has 209. So, when it goes for the alpha decay, then due to the alpha decay, now a different nuclei will be formed that I am going to indicate by the symbol X. And the atomic number of this element will be 82 now. Now, the mass number will also get affected, but since we are talking about the position of elements in the modern periodic table here, and this position of element is decided by the atomic number only. So, here we are going to calculate only the atomic number of this element. Since the atomic number is 82, so now this atomic number is different from the atomic number of parent nuclei. So now the position of this element X will not be the same what the position was occupied by the polonium in the periodic table. If I consider the position of this polonium in the periodic table, then this polonium is present in the nitrogen family and the group number of this polonium is present in the oxygen family and the group number of this polonium in the periodic table is 16 group, or we can say that this group is 6A group. Whenever it goes for the alpha decay, now this atomic number is decreased by 2. So now the position of this new element will be displaced 2 position to the left in the periodic table in regard to the position of this parent element. So now this X element will be placed 2 position leftward and now the position of this element will be 4th A. Same as if this polonium I consider this element undergoes beta decay. So as we know that whenever the beta decay occurs, the atomic number will increase by one value and now the atomic number of this element will be 85. Since the atomic number is going to be increased by 1 and elements are arranged in the modern periodic table in the increasing order of their atomic number. So now this new element X will be displaced one position to the right in the periodic table then compared to this polonium. Since the position of polonium was in 6th A group, so now in the same period this X element will be placed in 5th A group. These positions can be more clear if we consider the position of these elements in the periodic table. Now, this example will be more clear to you when we will be considering the position of these elements in the modern periodic table. Here we can see that this polonium, it is placed in the 6th A group and this is the position of this polonium with the atomic number 84. Whenever this polonium will goes for the alpha decay, now it will be converted into a element with the atomic number 82 and it will be lead. And here we can see that the position of this lead is two place leftwards as compared to this polonium, and now this the group number of this polonium will be 4th A. Same as when this polonium goes for the beta decay, so now the atomic number will be 85, and this 85 atomic number is for astatine, and this astatine is placed in 5th A group. So here we can calculate or we can find the exact value of elements after the radioactive disintegration whenever they goes for the alpha or beta decay. Now we will be doing some practice based on this rule, such as a question is given to us and it starts with the element radium. Radium has the atomic number 88 and the mass number it has 226. The position of this radium in the periodic table is also provided to us. This radium is a part of alkaline earth metals which are placed in second group or second A group, and the period of this radium is 7th period. Now, this radium goes for the successive emission of some radioactive particle. Like first this goes for the emission of one alpha particle, followed by the emission of one more alpha particle, which is further followed by the emission of one beta, and further by the emission of one alpha particle. Now, after the emission of these four radioactive particles, it is converted into a different element which is termed as D element here. And now the question is about the position of this element in the periodic table. They are asking about the group number of this element and the period number of this element. Now, to solve this question, since a lots of radioactive particles is going to be emit, so now we will solve this question step by step. Now, for consideration, if I consider that whenever this radium goes for the emission of one alpha particle, it is going to be converted into a nuclei with a symbol A. And as I am to find the position of this element in the periodic table, so it will be decided by the atomic number of this, and the atomic number of this will be 2 points less as compared to the atomic number of radium, and that will be 86. Since it is 2 points less as compared to the atomic number of radium, so now the position of this element will be 2 position leftwards in the periodic table. It was placed in second A group, so when we move 2 positions leftward, now it will be placed in 0 group. Or we can say that the group number is 18th here, but now the period will be 6th period. Same as if I move forward, then again this A element is going to emit one alpha particle, and now by the emission of one alpha particle, if I consider that it's going to be converted into a nuclei B. Now the atomic number of this element B will be 84, and it will be placed again 2 position leftwards in the periodic table. So now the group number for this element will be 16th, because initial one was having 18 group, and the period will be same, it will be placed in 6th period. Whenever this will move for the emission of one beta particle, now consider that it will be converted into a nuclei C. The atomic number of this nuclei will be 85 now, and since it is 1 times greater, since it is 1 point greater as compared to the atomic number of B, so now the position of this will be 1 position leftwards as compared to the position of parent nuclei B, and now the position will be, it will be placed in 17th group, and the period of this element will be 6th period. Now on the basis of the position of this nuclei C, we can find the position of the nuclei D. The atomic number of this element D will be 2 points lesser as compared to the atomic number of C, and now the atomic number will be 83. Since the atomic number is 83, so the group number of this element will be 15th group, or we can say that this one is 5th A group, which is the nitrogen family, and the period number will be same, it will be the part of 6th period. If you don't want to solve the question like this, and you are having the idea of the position of elements in the periodic table, then simply you can solve this by, like this one is the position of radium. Whenever it will go for the emission of one alpha particle, now the element that will be formed will be radon, and this radon is placed in 0 group and the period is 6 period. By the emission of one more alpha particle, the new formed element will be polonium, and the position of polonium is 6a group and the 6a group and the period is again 6 period. Whenever this will move for the emission of one beta particle, atomic number will increase by 1. The atomic number will be 85, and that is they are asking about the position of this state time, that is 7th A group, 17th group, and the period is 6th period. When it will emit one alpha particle from it, so the element formed will be bismuth, and this bismuth is 2 position leftwards as compared to the position of this acetylene. So this is how we can solve these kind of questions that are based on this group displacement law. So these are quite easier, but wherever you are going to solve the question based on the radioactive disintegration of lanthanoids or actinoids, need to be a little bit careful there. Like for example, if I talk about the element that is uranium. Uranium has the atomic number 92. Whenever it's going to emit one alpha particle, now the atomic number of the new formed element will be 90, and this element I am going to consider as X. So as we read initially that whenever the emission of one alpha particle occurs, the position of the new formed element will be 2 position leftwards as compared to this parent nuclei. But surprisingly, you will be finding that the position of this new formed element X is same what the position uranium was having. Uranium is an actinoid and it is placed in the third B group with the period number 7th. And this new formed element, it will be again having the group number 3rd B, and the position of this will be 7th period. So because this is a part of lanthanoids, as we know that in this periodic table, this lanthanum and the 14 lanthanoids followed by this lanthanum, they all are placed in this 3rd B group, and the position of and the period number for these will be 6th period. So that is about lanthanoids. One is lanthanum followed by 14 lanthanoids. These 15 elements are placed at the same position in the periodic table, and the position of these will be, the group number is 3rd B group or the 3rd group, and the period for these is, the period number is 6th period. Same as if I talk about the actinium followed by 14 actinoids, then all these 15 elements are again having same position. They are placed in the 3rd group, that is 3rd B group, but the period number for these 15 elements is 7th period. And the atomic number that is covered by these lanthanum and lanthanoids is, lanthanum has the atomic number 57, and the 14 and including the 14 lanthanoids, these 15 elements will be covering the range starting from 57 to 71, and the atomic number that is covered by these 15 elements is starting from 89, that is the atomic number of actinium, plus 14 elements, and the range goes to 103. So whenever the question is going to be asked and the element has the atomic number in these two ranges, then need to be careful there, since if the atomic number comes in this range, so the element is going to be formed, so the element is formed by the alpha decay or beta decay or whatever the decay is there, but it will be placed in the 3rd B group, and the period according to that will be decided. Such as if I talk about the uranium, so uranium is having atomic number 92, that is a part of this range. So since the atomic number is 92, and after that it is going to be formed a element with the atomic number 90, and this 90 again comes in the same range. So the position of this uranium and the new formed element X will be same. It will be 3rd B group and the 7th period. But when this uranium goes for the emission of 2 alpha particles, like I'm going to start with the uranium 92, it's another one example, but now this time it's going to emit 2 alpha particles. So now, due to the emission of 2 alpha particles, the new formed nuclei will be having the atomic number 4 points lesser as compared to the atomic number of this uranium, and now the atomic number will be 88. Now this 88 is not the part of this range. It doesn't comes in the range of this actinoids, as well as it doesn't comes in the range of these 14 lanthanoids. So now the position of this X nuclei we can decide, since it is 1 point lesser as compared to this, as compared to the range of these 15 elements. If the atomic number of this X nuclei would have been 89, so it would have been placed in the third B group and the seventh period. But now the atomic number is 88, that is 1 point lesser. So now the position of this X nuclei will be one position leftwards in the periodic table, and as we move one position leftwards to the third B group, the position of this will be second A group, and the group number will and the period number will be same. It will be the part of seventh period. We can also prove this by looking at the periodic table. Initially, they have started with the uranium. Whenever it emits one alpha particle, now the new formed element, new formed nuclei will be thorium, and this thorium is again placed in the third B group, and the period number is 7. But when this thorium goes for the emission of one more alpha particle, now it will be converted into, first it will be converted into actinium, followed by the conversion into radium, and as the radium has the atomic number 88, so it is the part of this second A group, and the period number is 7th period. So that is how we can solve the questions based on the lanthanoids and actinoids. Like, while taking one more example, if I talk about the position of curium, the symbol is Cm, and it is again an actinoid which has the atomic number 96. So when it goes for the emission of one alpha particle, according to the normal rule, the position of the new formed nuclei should be changed, but it will not going, but here it will not going to be changed, since the new formed nuclei X, it will be having atomic number 94, and whether the atomic number is 96 or it is 94, they are the part of this range, and all the nuclei which are present in this range, which comes in this range, will be placed at the same position, and the position will be third B group and the seventh period. So that is how we can solve these kind of questions, and this is about the group displacement law.